everyone, welcome back to my YouTube channel. So today I'm going to explain to you how you should answer the quiz 3 chemical kinetics. So altogether we have 3 different questions, and let's get started with the first one. Question number 1. Hi dissociate to form iodine and hydrogen if the concentration of Hi change at the rate of 0.45 mole per second indicate the rate of appearance of iodine. So, how are you going to do this question? So the first thing that you need to do is that you need to write a balanced equation for this reaction. So it states here that Hi, it will dissociate to form hydrogen and also iodine, right? Alright, so from here you need to see the H2 and I2, but at the reactant is only H and I. So you need to balance this equation, therefore you need to put 2 around here. Let's refer back to the question. So given to you, if the concentration of Hi changes at this rate, and you shall indicate the rate of appearance for the iodine. So since you already have this balance equation, so you already have the value of the Hi. So it means that negative half delta Hi delta T is equivalent to delta I2 delta T. And then in the question given to you the value for this one. So the value of this is equivalent to 0.45. So in saying that, negative 1 over 2 times 0.1.45 is equivalent to delta iodine over delta T. So you just need to calculate here from your calculator. So you shall get delta iodine delta T is equivalent to 0.225 mole per second. So this is the final answer for this question. So altogether you should get 5 marks. So 1, 2, 3, 4 and 5. 5 marks altogether. Question number 2. Predict the percentage of material that shall persist after 80 minutes if its half-life is 20 minutes and the reaction follow the first order reaction. So the clue for this question is that it follows the first order reaction. Therefore, you need to use the formula for first order reaction. The first order reaction, the formula is ln AT is equivalent to negative KT plus ln A naught, right? So A naught is the initial concentration and AT is the final concentration. So it says here that predict the percentage of material that shall persist after 80 minutes, and then its half-life is 20 minutes. So since you have the half-life, means that you can know the value of K. So the half-life for the first order reaction is equivalent to ln 2 over K. Given to you, the half-life is 20 minutes. So 20 equivalent to ln 2 over K. So K is equivalent to ln 2 over 20. So you shall get 0.0346. So this is your K. So you already have your K. And then you need to use back this formula to predict your AT. So ln AT is equivalent to negative K. So your K is 0.0346 plus ln A naught. So what is your A naught? So definitely at the beginning of the reaction, it will be 100%. So 100%, 100 divided by 100 equivalent to 1. So you shall get ln AT is equivalent to negative 2.768. Alright, and then you need to get what is AT, not ln AT. So your AT is actually equivalent to negative 2.768. So you just need to press your calculator. You should get 0.0627. But in the question, you were asked to predict the percentage. So by using this value 0.0627, you need to times 100%. Therefore, you should get 6.27%. So this is the final answer for this question. So altogether, you should have 9 marks for this question. So the first mark is the correct formula, and then another formula for your half-life, and then you put the correct value and you show me the calculation and the answer for your K. And then you need to show me the correct value that you put inside this formula. Then you show me how you get the value of AT. Then you need to know how to calculate the percentage, and lastly is your final answer. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So altogether 9 marks for the second question. Alright, the last question, question number 3. It took 143 seconds for 50% of a particular substance to decompose. If the initial concentration was 0.06 molar and the decomposition follows the second order kinetics, determine the rate constant for this reaction. So when you look at this question, you need to understand that if it have already decomposed for 50%, it means that this is the half-life. And then from the question, it states here that it follows the second order kinetic. So you need to use the second order kinetic formula. So the half-life for the second order is equivalent to 1 over K times A naught, where A naught is your initial concentration. Given to you, it took 143 seconds for 50%, means that the half-life is equivalent to 143. So 143 equivalent to 1 over K, which is the thing that you need to calculate, and then the initial concentration given in the question is 0.06 molar. So from here, you should be able to calculate the value of K equivalent to 8.58K equivalent to 1. So K equivalent to 1 over 8.58. Therefore, your K should be equivalent to 0.1166 liter over mole per second. So from this question, you should get altogether 4 marks. So 1 mark for the formula, another mark if you put the correct value, and you show me the calculation, and lastly the final answer. So all 4 marks altogether. So this is all for our discussion for the quiz question. I wish you all the best for this semester, and see you again next week in the next chapter, chapter 4.